So the fuel now coming from the water through the electrical polarization process going into resonance meaning that we're actually tuning into the dielectric properties of water, and it allows us to reduce amps down, flow down to a minimum, and allow voltage to take over that disassociates the water molecule on demand. And those fuel gases are now coming through this electronic injector system as you see here. So basically we're now feeding the ionized air from the gas processor. We're now also taking the water fuel gases that are now coming from ordinary water. We are now mixing it with the non-combustible gases, the ambient air gases, and regulating those control of the fluid mediums or for fluid mediums. And as a result, now we can tune in and allow this engine to run off of natural water. This system's approach, this particular unit here is referred to as the VIC, or the voltage intensified circuit technology. This is being miniaturized down to a very small, lightweight system. This is demonstrated in our systems engineering approach on the technology that we can apply it to other applications, not only in the transportation area but also in industrial applications. So it was paramount that we would demonstrate and have the technology solved for design engineering, retrofitting to existing energy-consuming devices, whether it's being run in an internal combustion engine or a diesel engine or hook it to an industrial process. So all of these design interfacing technology is now being solved. We are in the latter stages of what we call the pre-engineering system, which will now allow us to miniaturize the technology once we're completed on the design applications and take it into mass production. I'll give you a classical example of this. We've also developed from this technology which we call the water fuel cell injector. And basically this injector now is a miniaturized water fuel cell or miniaturized resonant cavity. And this technology now allows us to simply replace, we can bypass this part of the system's approach and now simply replace the spark plug with the water fuel cell injector. And as a result now we can run the water up to the injector, which is now being processed and being exposed to a very high pulse voltage frequency. And as a result, as the water fuel is being going into the system, then the explosion takes place inside the cylinder. Therefore, it makes this an extremely fail-safe, operable system. The cord that you see here is strictly hooks up to a very high intensity voltage pulse, and we restrict the amps to cause the electrical polarization process, which in turn the voltage amplitude now takes it and goes in the ionization state to perform the hydrogen fracturing technology. And then in turn the high pulse voltage frequency now allows the ignition of the gases. So therefore we do this electronically. And so this technology has taken us down to the water fuel cell water fuel injector as you see here today, which gives us a very economical way of simply converting and running a conventional car on natural water. So basically what we do is we feed ordinary natural water in here, non-processed natural water. We now feed the ambient air gases being ionized. It's being mixed with the water. And then we mix the non-combustible gases going in the system that regulates the control and so allows us now to release the thermal explosive energy from hydrogen and do it on a controlled means.